Good morning again, everyone. Welcome to our second SDS2 2021 webinar this morning here. We talked about kind of new and enhanced connections, just general type connections in our previous webinar this morning. This time we're going to look at seismic connections. I'm going to kind of do a similar drill as last time here. I have a poll question that we're going to run, just to give everybody a little bit of time here to join in the webinar so they don't necessarily miss anything. So what we're interested in here, what I want to see is what version of SDS2 did you first learn on? So did you first learn here 2021? Obviously, you would have been learning this year on it probably, or within the last couple of months. So that'd be interesting to see. You know, and then 2020 would mean you're fairly new. 2015 to 2018, that'd be within the last 5-6 years. And then we have a 7.0 to 7.3 range, which would be, to give everybody an idea, I learned on version 7.01 something, I believe. So it's fairly early 7.0 versions. That would put me in about the 15-year range now. So I've been on SDS2 and using SDS2 for about 15 years. So, and then if you're before 7.0, well, that could be a large range because that's going to go back to what, or mid 80s time frame potentially. Not that that's everybody, but yeah, it could be about a 20-year span there. So. Interesting results. So looks like about half of you are before 7.0. A quarter of you are 7.0 to 7.3. Another 17% within the last 5-6 years. And then we got about 9% of you within probably about the last year or so. So good mix there, all good information. I'd love to see different stuff like this. So we have again here presenting myself, David Zabka, and then I have Colin Kyrlieber here with me again to answer some of the potentially more in-depth things that we run into here with the seismic connections. So again, same drill. I'm going to turn my webcam off so that you can focus in on the presentation and the software demonstration portion of things today. If you do have questions as we go, use that questions pane in the GoToWebinar toolbar there, and we'll get to those as we can. Try to get to majority of those at the end here. So. Take a look at our agenda. So we'll look a little bit what's new, what's been updated in the 3rd edition seismic manual. That has mostly to do with some brace frame checks and things like that, nothing groundbreaking. And then we'll take a look at the ordinary moment frames and moment connections for that. We'll take a look at the bolted flange plate moment, or sometimes referred to as the BFP. That's included in the AISC 358 pre-qualified moment connections for seismic moment frames, and that covers SMF and IMF frames. We'll briefly look at the proprietary moment connections that are in SDS2 as well as that AISC 358. Those are all going to be custom plug-in type of things. So since those are not connections that we design, those are proprietary design, we require a plug-in for those. But those plug-ins really help with the coordination between you as the detailer fabricator and those companies doing those proprietary designs. And then we have some proprietary designs that are not necessarily in the AISC 358 because that's only for seismic moment frames. There's a couple others. Core brace is a good example of this, where you know, that's a BRB, so it doesn't fall under that AISC 358, but we do have a plugin for it. So So here's our changes, that are significant. Obviously not a lot in that third edition seismic manual. Colin, could you kind of maybe explain this a little bit and what this entails?
Sure. So in braced frames, there weren't very many changes in the third edition. There are some small changes to the format of formulas that we made. That doesn't really amount to enough to even list on this slide. The biggest things we did, we now have post-buckling checks on 2-point braces. So you'll see some of those limit states are ran twice in the expanded formulas, once with the full compression of the other brace and another time with 0.3 times that compression, which is the post-buckling load. And you'll also see we've updated the interaction formulas that we use in those in the gusset stress calcs. So we used to have just a linear interaction formula, and we now use the formula that's shown in the design examples in the seismic manual. You can also find that formula in part 9 of the regular steel manual. That's the extent of the braced frame updates that we had to make.
Okay, very good. Then we kind of move into the ordinary moment frames, or OMF, for seismic. So Colin, again, I'll kind of turn it over to you and let you take it over here on this one.
Okay, so in previous editions, we the seismic moment frames kind of lagged behind the seismic brace frames. So we made, you could see detailing changes within the model if you selected seismic. Now we have fully designed connections. So our OMF connections are designed based on section E1. You'll see the auto moment load is now that 1.1 times RY times MP divided by alpha S. You'll see if you have an OMF, we no longer do those special detailings of the column flanges and the column web stiffeners, or sorry, column web doublers. You'll also see we've had to introduce a new load on the load tab of member edit, because with these seismic connections, the panel zone is designed for a different moment than the rest of the connection, being the flange stiffeners and the connection itself. So we now split that old moment load into 2 loads, one being the old moment load and the other being the load that's used just for the panel zone design. So that would be the one that affects the web doubler. Let's see, there is no scripted way to calculate an auto shear load for an OMF connection. So if you leave the shear load at auto, you will still get the old non-seismic value. However, we'll show a note on the design report that includes the ECL, and the ECL is a part of the load combination that should be used to come up with a design load. So we provide that. We do continue to do the weld access holes according to table 1-1 of the seismic manual. And currently, the only connection we've had time to make sure we have a fully supported design for is the moment shear tab connection.
Okay, good information. So if I'm not mistaken, just to add a little bit to this, that table 1-1 with the access holes, that did expand just a little bit. So there's an additional O-type access hole in there with some different sizing. Is that correct?
Yep, that's right. So you'll see that updated in setup, and you'll also see that updated in our ship material files.
Okay, very good. Our next topic then is going to be intermediate and special moment frames, or IMF and SMF. And again, Colin, this is better your area to explain than mine.
Okay, the design of these 2 frame types is based on AISC 358. So that document only mentions LRFD, so these connections will only be supported for LRFD designs in SDS2. The the auto moment, and this time auto shear loads are as specified in that AISC 358-16. So we assume MPR, that's the maximum probable moment at the plastic hinge location. And then we make use of free body diagrams to determine the load that would be at the column face. We are doing full designs now, so we've included the overstrength factors in the flange limit states. And you'll see we also implemented those 2 special fee factors for these seismic frames. So we have a fee factor of 1.0 for ductile limit states and 0.9 for non-ductile limit states. The web doublers are designed according to the appropriate section of the manual. So for IMF, that's E2.6E, and for SMF, that's E3.6E. The flange stiffeners likewise are designed according to the provisions. That is E2.6F for IMF and E3.6F for SMF. We also do calculate a story shear load, and we do that according to some of the design examples that you can find in the manual in part 4. So unfortunately, we don't have an auto button on that shear load, on that story shear load in MemberEdit. What we have done is we print it as a note on the design report, and then you can go back into MemberEdit and populate that value. And as David mentioned, the connection that we are currently supporting that's fully designed is a bolted flange plate moment connection. So that's just a different name for a bolted moment shear tab connection.
Okay, very good. Thank you again. So just a little more in depth on this BFP connection. There are some special requirements in the AISC 358 for that. So you're going to notice some specific grade materials to be used for the plates, the welds. So to attach those flange plates to the column, those are going to require CJP welds. Your single plate shear connections have some requirements there as well. Out of the box, SDS2 is going to provide you with the double-sided fillet weld. You do have some control over that within the connection component window. And then there are some specific bolting requirements as far as, standard round holes in the flanges. Flange plates can be standard round or oversized. Bolt type, so bolt types you're going to notice are limited A490 or F2280, and those are X type bolts, so the threads shall be excluded from the shear plane. Tells me those are going to be X type bolts. Maximum bolt diameters, and then everything's got to be symmetrical and some limitations there. So some fairly strict requirements here to meet those pre-qualified moment connections. So some of the things within SDS2 that you're going to notice, again, some of these things are not new to our project settings, but they're just things that I want to point out affect these types of connections. While there are a couple new settings, most of these really aren't, just a reiterating where you're gonna see some effect within the connection design. So project settings, under our design settings, we have a seismic moment frame checkbox to turn that on by default, and then below there we'll see a type of moment frame, whether that's OMF, SMF, or IMF. Our bolt settings, so we have default bolt settings for our moment bolts and such. Moment plate design settings, so we've always had those for a long time in SDS2. Those are going to affect things like our doubler, stiffener design. Keep in mind though, with those doublers and stiffeners on the especially on the IMF SMF, there are some pretty specific detailing requirements for those to clear the K distance on the column and such, limits the contact that we can have there. And we'll see that happening as we go through the demo here in a little bit. So, you know, preferred plate sizes is going to control our plate grades for those flange plates. So I mentioned if we're having to do those 358 pre-qualified moments, you know, we need to make sure that default is set up to meet those requirements. And then we mentioned the seismic weld access holes as well for the OMF connections. And then again, within our beam edit window, we're actually going to see an entire new seismic tab or area within the beam edit window where we can specify this to be a seismic moment frame member. In the past, I believe that option was actually a left and right end option. Well, that didn't make sense. It's really a one or none type of deal. It's an all or nothing deal. So we moved that into its own section that's specific to just the member and not to the ends. We can override and change the type of moment frame in here, IMF, SMF, or OMF. And then we have different things here, the story height above node or below node that is going to potentially affect our story shear that Colin mentioned earlier, for us to be able to input that, as well as that uniformly distributed gravity load that we're going to see there. Again, it's not a end reaction, it's a distributed gravity load across that whole member, so it doesn't make sense to be an end field. It's just for that entire member. And then we're going to see the new panel zone moment load, which affects the design of our column web doublers. Moment bolt type here, that affects obviously the bolt type in the flange plates. So we'll see all these and where they're all at as we go through the demo here, just kind of hammering the points home a little bit. Now, the AISC 358 proprietary or pre-qualified moments include some proprietary design. So these are different designs that have plugins already developed and are already available to use within SDS2. So, you know, side plates probably the one that's been around the longest. We've probably seen that a lot. You know, you can get the components and such for that plugin. You have to get those directly from SidePlate, something that they spent a lot of time developing. So they distribute those plugins for that. You can get there. There's probably several webinars that we've done in the past, but there is a webinar specifically here. I think we did one within the last year or so that you can check out for more info on the SidePlate. There's also a Simpson strong tie yield link moment connection that's included in the 358, and Simpson strong tie has developed plugins for SDS2 for their moment connection. Again, there's components for that. Simpson strong tie specifically distributes that. You can get on their website and get those directly from them. They have a video on there, pretty brief video. Theirs is pretty simple, actually, pretty slick. They have about like 8 to 10 different sizes that you pick from a list, and it populates everything based on that, so it works pretty well. And Simpson Strong Tie, are actually hosting a webinar series on their different plugins for different software packages in the near future. The one featuring SDS2 will be April 15th at 1 p.m. Central Time. Durfuse Frames is pre-qualified for the AISC 358, and they will be in the next edition, scheduled to be released in 2022. For more information on all this, you can refer to their ER610 report, which we provided the link for here. For California specifically, the Durafuse frames moment connection is pre-qualified for the CBC and for the City of LA, again, in that report that we've linked to here. You can get their components for that from our toolbox, or we did a webinar here within the last couple of months demonstrating how that all works, so you can check that out. Core brace, so that's BRBs, and you know, again, 358 is specifically for moments where this falls under a whole different category. You know, I believe it's the AISC 341 is the seismic, includes the seismic provisions that core brace would be going off of. So they have components on our toolbox. I did a webinar with them here within the last probably 6 to 8 months on how that all works as well. So you can check that out. And let's take a look in SDS2 then to kind of see some of these settings, where they're at, how they work, and kind of check out what it looks like in the model here. So, you know, our project settings, we talked about first off in the design settings, under our beam design loads, okay, we have that seismic moment connection design. We have the seismic moment frame type, which is a new option. So we can choose ordinary, intermediate, or special here. So again, that's just our default. You know, our moment plate design settings, these are still going to affect how things are done, but still has to meet the requirements of the seismic if we're specifying that it's a seismic moment frame. You've got your flange plate clearances, seismic weld access hole. So you can see we have the new O hole type in here. That was that's an expansion on the seismic from AISC. So we've got that included in there. And other things, so bolt settings, we talked about kind of some specific requirements for bolt types and such. I'm going to change my moment bolts over here to, let's do A490X. So if you remember from those requirements, it was A490 or F2280, and shear, the, excuse me, threads were to be excluded from the shear plane. So we have those bolt settings there. And then under our standard fabricator connections for our preferred plate sizes, here's where we can set up our moment flange plates, the default grade, limit thicknesses if we wanted to here. Grade is kind of the specific one I'm looking for in this particular case. Am I missing any important settings within here, Colin, or is that cover most of the things that we're gonna kind of really be important to us here?
No, that covers it. The thing I would add is you saw on that BFP slide that A36 is allowed for flange plates, but due to some of the limitations they have on the length of the bolt group on the flange, it appears that really the A57250 is the way you need to go in order to get a connection.
Okay. So in modeling, again, I'm not going to touch on the proprietary stuff today. We've done in-depth webinars and everything on all those proprietary type connections. So you could go back and check those out. I'm really going to focus on the moments today. So, you know, for ordinary moment frames, we discussed that we can do the shear tab welded moment. We have in here this new seismic connection that some of you have probably noticed if you've had 2021 open already. So talked about that in the slide here. We're just overriding that moment frame checkbox that I showed a minute ago, and then our frame type. So I did have it turned on, so automatic should give you a moment frame. and the type should be OMF in this particular case. If I come in here, choose a shear plate, and go to my moment to choose a welded moment. Okay. I'll go ahead and say okay. Notice we get that moment here. For the OMF connections, there are no special requirements for these doublers and stiffeners, so those are going to look similar. In the previous versions, we didn't necessarily have control over which type that was, whether it be OMF, IMF, or SMF. So when you had a seismic moment frame chose in the previous versions, you would always see those doublers and stiffeners meeting the special requirements. Now they're not if they don't have to be. Then we talked about the panel zone moment load that controls, or the doublers, web doublers in that column are going to be designed based on. And excuse me, that am I doing something wrong, Colin, here? Or is that only applied to the other moment frame types?
No, that applies to OMF as well.
Go ahead and grab my, let's go ahead and there we go. Okay.
If you mark that auto, this is another thing where that load is, according to the manual, supposed to be based on load combinations. So it should be based on an actual design moment, but if you mark that as auto, we just populate that with the same magnitude as that one you're hovered over above there.
As the regular moment load there, right. Okay. And good information to know.
And there should be a design note to that effect.
I'm sorry.
I was just saying there should be a design note on the report to that effect that calls that out to your attention.
Okay, very good. So now you can see as I start filling in that and get that panel zone moment load, we can see now we're seeing some web doublers designed based off of that. So again, we didn't have that in the past, so we would kind of had to do some things that weren't necessarily meeting all the requirements. We've corrected all that and got everything necessary in there for that now. I'm going to move over here to a different joint then, and in this particular case here, we'll focus on that BFP from the 358, and I'm going to go ahead and set this then to a special moment frame. So in the case of the IMF and SMF, I have my story heights here. I can choose, and that, I believe, correct me if I'm wrong, is I think it was laid out in the slide previously, but that's from half nominal depth of this beam to the beam above, and then half nominal depth of this beam to the beam below. Does that sound correct?
Yep, that's right.
Very good. So punch in that information just for time purposes. I've got a form here that fills out my connection type, my moment type, all that. And we can see now we're getting that in the preview. Hit OK. So here we get that bolted flange plates. You can see we have the CJP weld attaching to the column as was specified in the 358. There are some CJP welds on the stiffeners there also. These do have special detailing requirements, and they're mostly to do with the clearance around that K distance. So we're going to see some additional clearance there, and we're meeting those requirements. And if we go ahead and look then inside the edit window, go down to the loads again. My form that I loaded had some loads pre-filled out here, so that's why we're seeing those here. We talked about that story shear, okay? So we're not seeing that story shear. We don't have an auto box for that right now. I'm gonna run the expanded calcs and get the expanded calcs up here. So just to give you guys an idea of where that's at specifically in here, where some of those notes are at regarding this stuff. My computer's probably getting tired of doing webinars this morning. Taking a little longer than I would expect. Okay, there we go. Now we got to wait on Bluebeam to open. But everybody probably runs with that open typically anyway. So here we go. So here's our connection design report. We were on the left end of this. I believe if we check out the notes and conclusions, so again, in the previous webinar, we talked about how this stuff is bookmarked nicely. I hit my notes and conclusions, and within here, we can see the note about our story shear force that we discussed and what it's based on. And we can see it's coming up with minus 89 kips here. So we can go back and I hit the wrong button. So we can punch in our minus 89 kips for our story shear. And it is important to note, actually, in this case. So it is important to note in this case that depending on that load and how things are figured, we can end up with a kind of more economical connection by entering that load. So we may see, you know, thinner materials or smaller materials, things like that by entering that load. So it is important that we get that punched in there. That's not going to be every case. Obviously, putting that in there could result in a heavier connection as well, but there are cases where it might be more economical. So important topic or thing to note there. So anything I'm missing here, Colin? Is that kind of cover everything? Anything important you'd like to point out here that I may have not gone over yet?
Yeah, no, nothing comes to mind.
Okay, very good. So that's kind of the rundown on the seismic changes that we've done here. So kind of biggest thing to remember is on the OMF connections. We're currently doing that shear tab field welded moment connection, and then to meet the for the AISC 358 for IMF and SMF, we do this BFP connection along with 3 different plugins or components that we have for the proprietary design, and then, you know, just like everything else in SDS2, the work's never done. There'll always be continual development and improvement on stuff. So look for more in the future. I do want to run a couple of poll questions here again at the end of this webinar to get some information from you guys as we start running these polls. Questions that you had come up or may have, go ahead and put those in the questions pane over there on the GoToWebinar toolbar. So the first poll, while we're waiting on those questions, I want to run is about the AISC 358. So there are some different designs in there outside of this BFP. I'm curious on which one you most commonly use or which one most commonly comes across in design drawings for you guys. And I'm pulling up the yep. So we here's a good question as you guys are answering that poll, and it has to do with the clips. So on the clips here on these stiffeners, I believe, and I'm going off of memory here, Colin, you could correct me if I'm wrong, but I believe for the seismic requirements on these stiffeners, that we have to clear that K distance on the column by at least a ½ inch?
No, I need to apologize. I don't remember that number off the top of my head. It is greater than a ½ inch, so.
Great, okay, greater than a ½ inch. Okay, so, so greater than a ½ inch, I don't know the exact number off the top of my head, but the, yeah, those clips are to meet seismic requirements set by the 358. So, and it looks like a lot of you are seeing the reduced beam section, or what's typically referred to as a dog bone connection. But about 20, almost 25% of you are answering that. So that's interesting, as I don't come across that one myself as often as I used to about 5 to 10 years ago. So that's interesting. Then about a third of you are seeing the extended end plate, and another third are seeing the unreinforced flange welded web, and small number seeing double T's, and about 7% on the slotted web. So we'll go ahead and close that particular poll. I think it is already, excuse me. And the next one, the next poll we're gonna throw up there is about the 358 and which one would provide you, excuse me, we're gonna go with the proprietary connections that you've used in the past, if you've already used those in the past. So we talked about those that we have already. I'm curious, which ones of those have you already taken advantage of and used in the past? So again, if you have any other question, so there is a question on, let's see, the X bolt threads. So I don't necessarily know the answer to this. Do we actually increase the length and adjust the length on those X bolts to make certain that the threads are excluded from that plane, Colin?
Today we do not do that yet. That would still be up to the detailer to confirm that.
Okay, good to know. So yes, so possibly area to be aware of that may need to adjust the length of those bolts to make certain that's meeting all the requirements we need. So, okay. So poll results here on the connection plugins that you've used. So looks like about a third of you have taken advantage of the side plate plugin, so that's good. Some of you are using that core brace plugin on the BRBs. That's good to know. And some of you are using that Durafuse frames as well. So nobody on the yield link from Simpson Strong Tie. That's interesting. We then have a final poll question on the, there are a couple additional proprietary connections that we don't have plugins for at this time. And we're curious if either of those are going to provide you a lot of value. So. Questions are coming in pretty slow here at this point, which is okay. So it looks like a small on the poll here. It looks like probably a small portion of you guys, about 5%, see the Kaiser bolted bracket, and about 7% are seeing the Connects Tech plugins. So again, all good info for us here. So yeah, questions are coming in slow here. I don't see any on there that we haven't answered yet. If you've got another question, love to see it up there. Otherwise, I'm going to go ahead and give the same spiel I always do. You know, we want you guys to please stay informed. We have a ton of information that goes out. We put a ton of information on our YouTube channel. All our webinars are hosted on, we have them directly on our website. I think you can go to the resources tab, and then there's a webinars area for us there where we have on-demand webinars or previously played webinars that you can get to there. We post a ton of stuff on LinkedIn, Facebook, Instagram, all that good stuff. So follow us there, watch that, check out our blog, toolbox. So the toolbox is where a lot of this plugin stuff that we've been talking about gets distributed. Now, not all of it, you know, SidePlate and some of those others develop their own plugins, they distribute that. But we're getting a lot of good stuff and content up there on the toolbox to check out. If you need updated training, definitely go there. And then again, love to see everybody this fall at St. Pete Beach, Florida for the SDS2 Summit. And just a big thank you again for attending today. Hopefully you saw both connection design webinars, the previous one and our seismic one here. Reach out to us if you have questions or need something else, maybe more clarification or something we didn't cover today. We'd love to hear from you. Contact support, get a hold of sales. And just again, thank you. Enjoy the rest of your day.